In this video, I'd like to do a couple of examples involving simplifying expressions with function notation where both the input and the output of the function are being affected. For this example, we're going to simplify the following expressions if g of t is equal to t over t plus 3. The first task that we have is to simplify negative 3 g of 1 minus t. The 1 minus t in parentheses, that indicates what our input is, and the negative 3 on the outside of the function is just a constant that we're going to multiply the entire result by. So I'm going to say negative 3 times, what else do we have going on here? So 1 minus t is what we're inputting for t. So in the numerator, I'm going to have 1 minus t, and in the denominator, I'm going to have 1 minus t, that's my input, right, plus 3. Okay, I did two things there, right? The input into the function is 1 minus t. So everywhere I saw t in this original function that I was given, I replaced t with 1 minus t. Okay, the other thing I did is I multiplied that result times negative 3, right? Because the outside of the function is being multiplied by negative 3. Okay, so let's clean this up a little bit. In the numerator, I'm going to have negative 3 times 1 minus t. And in the denominator, I'm going to have, let's see, 1 and 3 is 4, right? So I'm going to have 4 minus t in the denominator. And let's go ahead and distribute the negative 3 through up top. So we got negative 3 plus 3t over 4 minus t. And we can leave it that way. We could rearrange the numerator to be 3t minus 3 instead if you wanted to, but it makes no difference. It's fully simplified at this stage. In the next example, we've got g of negative 2t plus 1. Okay, so a couple of things there. Our input is negative 2t, so that's what we're plugging into the function for t, right? So I'm going to have negative 2t in the numerator divided by negative 2t plus 3, right? So I just substituted negative 2t everywhere I see a t in the function. And then to the outside of the function, to the result of that, I'm going to add 1. Now, at this stage of things, I would probably tell you, hey, it's okay to just leave it as is. Further on, as we continue our study, we're going to learn how to combine that into a single fraction, that expression. So I'm going to keep going here for the moment. I'll say I'm using a different color just to indicate this is some additional information here. In order to add two expressions, one of which is a fraction, you have to have a common denominator, right, to add fractions. So since we're adding 1, the common denominator here would be negative 2t plus 3, right? So negative 2t plus 3 over negative 2t plus 3 is equivalent to 1, right? And we have a common denominator. So we could then add those if we wanted to do this. Yeah. So negative 2t minus 2t in the numerator is minus 4t plus 3 over negative 2t plus 3. Now, it looks like a lot of you are going to be tempted to start canceling things there, right? Like, can't the 3's cancel? Isn't negative 4t over negative 2t positive 2? No, you can't do that because when you're adding and subtracting numerator and denominator, you can't cancel terms. It's only when you're multiplying. So we'll learn more about that later, but we have to leave this as is. Mainly, I'm wanting you to understand what changes affect the inside or the input of a function and what changes affect the output. Okay, so here's another similar example, but it's a different kind of function. So we just did an example with a rational function. This example is a radical function. So it says simplify the following expressions if r of x is equal to the square root of 5 minus 3x. The first task that I have is to find r of 3t minus 4. Nothing is happening to the outside of the function, right? The only thing that we're changing is the input. And I'm also noticing we have r of x, and yet I'm being asked to find r of 3t minus 4, so the variable is even changing. That's fine. It doesn't matter if the variable changes. It doesn't matter what is in that input. You could have r of Susie, and you'd put Susie in there for x, right? So I'm going to have the square root of 5 minus 3 times 3t minus 4, right? So again, the 3t minus 4 is my input, so I'm substituting that in for x. And simplify that from there. So I'm going to have 5 minus 9t plus 12. And 5 and 12 is 17. So 17 minus 9t. Okay, some of you might be tempted to say, oh, the square root of 9 is 3, but because we're subtracting the 9t from 17, we can't do that. So we just have to leave it as is. Okay, so let's look at this next example. We've got 5 times r of x plus 2 plus 4. Okay, so the 5 on the outside of the function and the 4 that we're adding on to the end, that's affecting the function at large, the output of it. The x plus 2 is the only thing we're changing about the input. I'm going to have 5 times the square root of 5 minus 3 times x plus 2 plus 4. Okay, so the x plus 2 is what I'm sticking in there for x, and the outside multiplier of 5 is what we're multiplying the radical by, and then we've got to add 4 onto the end. So let's clean up the radicand a little bit. We've got 5 minus 3x minus 6 plus 4. Okay, so 5 minus 6 is negative 1. So we have negative 1 minus 3x plus 4. And there's nothing more we can do with that. We've got to leave it alone. All right, so hopefully you're getting the idea of how to deal with a different kind of input, whether it be a numerical value or a whole algebraic expression. And also, if you have things going on the outside of the function, dealing with that appropriately to the entire function given.